So this is solubility and solution process, and this is the factors that affect the solubility. So the expression is like dissolves like. What does that mean? That basically means that polar dissolves polar, and nonpolar dissolves nonpolar. So this is an example of that down here, where I have oil, which is in a large organic molecule, is nonpolar, and water is polar, and so therefore they don't mix or they don't dissolve in each other. They're immiscible because of the fact that they're not alike. Another factor is the tendency towards disorder. Things want to become more disordered, not less disordered. And then the strength of the intermolecular forces. So molecular solutions are basically mixing of two parts that don't really interact. They're typically nonpolar molecules, so something like dissolving oil or oil-based paint into gasoline. The molecules really don't interact whatsoever there, but they do become miscible. For ionic compounds, we learn in chapter 4 about the solubility, whether something is soluble or insoluble. Well, that solubility depends on two things: the power of the hydration and the strength of the lattice energy. And they're opposite things. So lattice energy is what wants to hold the particle, holds the molecule together, or holds the crystal together. And power of hydration breaks the crystal apart. So lattice energy is a factor of the charge of the ion and the radius of ion. So sodium chloride is soluble, which means that it forms ions when I put it into water. So my sodium and my chloride have broken apart, versus silver chloride is considered to be insoluble. And we're going to learn in chapter 17 some of these actually do still form ions, but the majority of it stays here and is as a crystal and does not break apart. Okay, so this next image shows you basically the difference between them. Okay, so hydration is wanting to pull them apart, okay, and lattice energy is wanting to pull them together. And so basically for an ionic compound, if it's soluble, that means that hydration wins. If it's insoluble, that means the lattice energy wins, and it's a battle. And we're not going to actually quantify any of those, but I just want you to understand the difference. So this is a good multiple choice kind of question. And that is the end of this section here.